on to the final question of the homework, which is another trig question. We're given this result here, which is actually in the formula book, but they've given it to us anyway, which is kind of them, and we're asked to prove this trig identity. Hopefully you can spot the only way of getting cos A plus A is to write this as, cos 2A is to write this as cos A plus A. So all the B's we're going to turn into A's, and we're going to see what we get. So we get cos A plus A equals cos A minus sin A sin A. So we've done what we were told to do, but then we look at this and we discover it's not actually the way we want it to be yet, because they've got some sine squareds and no cos squared, and we've still got this cos squared here. So we're going to replace this using cos squared is 1 minus sine squared A. So we're going to write this as 1 minus sine squared A minus sine squared A is 1 minus 2 sine squared A, which is the result they asked for. We do need to show this intermediate step because it is a show that question and the answer is given on the sheet. So you do need to show all the working out steps. For the next bit, we're given an enormous great big pile of trig here and asked to show that it's this thing here. So before we do any trig questions, we should really write it out and do a little bit of planning. So I'm going to write this out and then we're going to do some planning based on what we're going to do for part B. So I've got 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3 equals sine theta, and then we've got a bracket. There is some stuff in this bracket, but actually it's not the most important thing, because what we need to do is have a look at this side and see how we can get there. We should notice that sine theta is a common factor, so every single term has a sine theta. So what we need to do is try and rearrange this so every single term has a sine theta in it. So this one here, that's easy. We can write it as 2 lots of 2 sine theta cos theta, and this has got a sine theta in it. Minus 3, we're now going to use the result from before, this one here that's got sine theta in it. So we're going to have 1 minus 2 sine squared theta minus 3 sine theta plus 3. So we're going to write out this, we're going to tidy it up, and then we're going to get to the result that they've got. So if they hadn't given us part A, the fact that there's a sine here would be a clue that when we do our cos 2A one, we want the one that's just got sine squareds in it. Because if we make this one into cos squared, then we're never going to get sine out as a factor. So tidying this up, we get 4 sine theta cos theta minus 3 plus 6 sine squared theta minus 3 sine theta plus 3. The minus 3 and the plus 3 cancel, so we get sine theta brackets 4 cos theta plus 6 sine theta minus 3 equals 0, which is the result we were asked to prove in here. So we've got a sine theta, we've got 4 cos theta plus 6 sine theta minus 3, which we got there. For part C, we're asked seemingly out of the blue to express this thing here in a specific form, which is going to be useful later on. You might also have noticed that this thing here is exactly the same as this thing here, so we are going to use this later on for some solving. So I've written out my 4 cos theta plus 6 sine theta. I've written out my expansion of r sine theta plus alpha. So this just came straight out the formula book. This is using the sine A plus B, multiplying it by r. So we get r sine A cos B plus r sine cos A sine B. So we get that. Pairing these up, pairing up the causes, these two have actually swapped sides. So we get 4 here equals r sine alpha. And on the other side we get 6 equals r cos alpha. Using the same method as we used in the previous question, we jump to tan alpha equals this one, so 4 over 6, which implies alpha equals, we're going to tan minus 1 this number, so we tan minus 1, 4 divided 6, which gives us 0.588. There's lots of zeros after this answer, which is quite nice. It's going to make our answers nice and accurate. 8800. I'm going to leave those there just so I can show myself and remind myself later on that this is an accurate version of this. We can also find r by doing r squared equals 4 squared plus 6 squared from the 4 and the 6 here. So we get r equals square root, I think this is square root 52, because we get 36 plus 16, we get 52. I think you can cancel this to 2 square root 13, but we could use square root 52 throughout. So we're asked to express, so we're going to write it as 2 square root 13 sine theta plus 0.588. Finally, if we look at part D for this question, we'll notice that this question starts with hence. And whenever you see hence, something that we've used before has got to be useful, and in fact has got to be used. It doesn't say hence or otherwise, it says hence, so using what you've already done. We should notice a couple of things. This form here, 2 sine squared theta, we've got a 3 cos 2 theta and a 3 sine theta. Here's our 3 cos 2 theta and here's our 3 sine theta. So we're going to expand this and try and make it look like that. So we get 2 sine 2 theta equals 3 cos 2 theta plus 3 sine theta minus 3. I've expanded the brackets, so I'm going to take everything over to the left hand side to give me 2 sine 2 theta minus 3 cos 2 theta minus 3 sine theta plus 3 equals 0. And now we bring back our sheet, we notice that this is exactly the same as this. So I'm going to replace the entire left hand side with this. So we get sine theta, open brackets, 4 cos theta plus 6 sine theta minus 3, close brackets here, equals 0. We should also notice from this part up here that we can express this 4 cos theta plus 6 sine theta as this. So we're going to put that in here as well for this bit. So we get sine theta, and then we're going to write this as 2 root 13 sine theta plus 0.588 minus 3 equals 0. This gives us 2 trig problems to solve. It gives us sine theta equals 0, which has solution 0. The next one is pi, but that's actually out of our range. It's not in our interval. But this one is a correct one of our solutions, so we're going to keep that for later. We also need the points where 2 root 13 sine theta plus 0.588 minus 3 equals 0. So this is where sine theta plus 0.588 equals 3 over 2 root 13, just by rearranging. I'm going to make a replacement here, and I'm going to use x as theta plus 0.588. We can see our range is going to be 0.588 less than x less than pi plus 0.588. And this is 0.588 plus pi 3.7. So we're going all the way up to 3.7. We get our first answer, we get x equals, because it's just in here, we sine minus 1 this. We get shift sine fraction 3 over 2 square root 13. So we get 3 over 2 square root 13, we get 0.429. And if we look, this is actually outside of our interval here. Not in interval. The next one we get on a standard sine graph, think about a standard sine graph, is going to be pi minus this. So we're going to do pi minus ants to get 2.7125. This is in our interval because we can see it's between 0.5 and 3.7. This is an answer for x. We get theta from x by doing x take away this number. So we're going to take away 0.588 to give us our final answer of theta equals 2.12, or 0 from before, because we got our 0 answer up here. And that's the end of that question.